For years, Toyota has been criticized for moving too slowly into the electric vehicle revolution. While rivals rushed to launch dozens of battery electric models, Toyota doubled down on hybrids, hydrogen technology, and a cautious long-term strategy. Many critics claimed the world's largest automaker had fallen behind. But Toyota has now responded with an announcement that has the entire automotive industry paying attention. Instead of simply releasing another electric car, the company has revealed technologies and manufacturing breakthroughs that could completely reshape the future of transportation. The announcement isn't just about one vehicle. It's about a roadmap that could redefine how electric cars are built, how far they travel, how quickly they charge, and how affordable they become. If Toyota succeeds, it could once again change the automotive industry the same way it did with the original Prius more than 2 decades ago. Toyota's latest strategy centers around one idea: making electric vehicles practical for everyone rather than simply producing the fastest or most luxurious EVs. This philosophy has guided the company for decades. Toyota believes consumers want reliability, affordability, durability, and convenience more than flashy specifications. Now it claims to have developed technologies that can deliver all of those qualities simultaneously. Perhaps the biggest headline from Toyota's announcement is its progress in solid-state battery development. Unlike conventional lithium-ion batteries that use liquid electrolytes, solid-state batteries replace the liquid with a solid material. This seemingly simple change offers enormous advantages. First, solid-state batteries can potentially store significantly more energy in the same physical space. Higher energy density means longer driving ranges without increasing battery size or weight. Toyota believes future vehicles equipped with these batteries could travel well over 600 miles on a single charge under ideal conditions. Second, charging speeds could improve dramatically. Current EV owners often spend 20 to 40 minutes charging at high-speed stations. Toyota believes future solid-state batteries could reduce that time to around 10 minutes, bringing EV charging much closer to the convenience of refueling a gasoline vehicle. Safety is another major benefit. Traditional lithium-ion batteries contain flammable liquid electrolytes that require sophisticated cooling systems and extensive safety engineering. Solid-state batteries are inherently more stable, reducing fire risks while allowing engineers greater flexibility in vehicle design. Battery longevity also improves. One of the biggest concerns among EV buyers is battery degradation over time. Toyota claims its new chemistry will better resist wear, allowing batteries to retain more of their original capacity after years of use. This could significantly increase resale values while lowering long-term ownership costs. However, Toyota knows that creating a better battery is only half the challenge. Manufacturing these batteries at commercial scale has proven difficult for nearly every company attempting it. Many startups promised solid-state technology years ago, but struggled to mass-produce it economically. Toyota believes it has solved several of these manufacturing challenges through new production methods. Engineers have reportedly simplified manufacturing processes while improving material stability, making large-scale production increasingly realistic. If successful, this would represent one of the biggest battery breakthroughs in decades. But batteries aren't Toyota's only focus. The company also introduced a completely new manufacturing philosophy designed to reduce costs while increasing production speed. Traditional vehicle manufacturing involves thousands of separate components assembled over numerous stages. Toyota aims to simplify this process through large structural castings, modular platforms, and advanced automation. By reducing part counts, Toyota can lower manufacturing complexity, shorten assembly times, and improve overall production efficiency. Fewer components also mean fewer opportunities for defects, supporting Toyota's reputation for exceptional reliability. Software is becoming another central pillar of Toyota's future. Modern vehicles are increasingly defined by their software rather than their mechanical hardware. Features such as advanced driver assistance, navigation, entertainment, battery management, and even suspension behavior are now controlled by millions of lines of code. Toyota announced major investments in software-defined vehicle architecture, enabling future cars to receive frequent over-the-air updates. Instead of requiring dealership visits for improvements, customers could download new features, performance enhancements, and security updates directly to their vehicles. Artificial intelligence also plays a growing role. Toyota is integrating AI into manufacturing, predictive maintenance, driver assistance, and energy management systems. Intelligent battery monitoring can maximize lifespan, while AI-powered production lines improve quality control and reduce manufacturing defects. Toyota's commitment to hybrids remains equally important. While many manufacturers have shifted almost entirely toward battery electric vehicles, Toyota argues that global carbon reduction requires multiple solutions. Millions of consumers still lack access to reliable charging infrastructure. For these customers, hybrid vehicles continue offering substantial emissions reductions without requiring charging stations. The company plans to introduce a new generation of hybrid systems that are lighter, more efficient, and more powerful than previous models. Improved engines, higher efficiency electric motors, and smarter energy management promise lower fuel consumption while maintaining Toyota's legendary reliability. Hydrogen technology remains another key pillar of Toyota's strategy. Although hydrogen passenger cars have struggled to gain widespread adoption, Toyota believes hydrogen still has enormous potential for heavy-duty transportation, commercial vehicles, buses, shipping, and industrial applications. The company continues investing heavily in fuel cell technology while exploring hydrogen combustion engines that burn hydrogen directly rather than gasoline. These engines could preserve traditional internal combustion characteristics while producing dramatically lower carbon emissions. Another surprising aspect of Toyota's announcement involves vehicle design itself. Future EV platforms are being engineered with improved aerodynamics, lighter materials, and more efficient electric drivetrains. Every improvement contributes to extending driving range without necessarily requiring larger batteries. Toyota engineers emphasize that increasing efficiency often delivers greater value than simply installing bigger battery packs. A more efficient vehicle requires fewer battery materials, lowering production costs while reducing environmental impact. The company is also developing next-generation semiconductor technologies for power electronics. More efficient inverters and motor controllers reduce energy losses during acceleration and cruising, allowing vehicles to travel farther using the same battery capacity. Charging infrastructure represents another important piece of Toyota's long-term strategy. Faster batteries alone aren't enough if charging networks remain inconsistent. Toyota is partnering with industry groups and governments to expand charging availability while improving compatibility across different charging standards. Sustainability extends beyond the vehicles themselves. Toyota announced expanded efforts to reduce emissions throughout its manufacturing operations by increasing renewable energy use, improving recycling processes, and developing more environmentally friendly production techniques. Battery recycling has become increasingly important as EV adoption grows worldwide. Toyota is investing in technologies capable of recovering valuable materials such as lithium, nickel, cobalt, and other critical minerals from used batteries. Recycling reduces dependence on new mining operations while lowering long-term production costs. Perhaps the most overlooked aspect of Toyota's announcement is its enormous manufacturing experience. Unlike many newer EV manufacturers, Toyota has spent decades perfecting large-scale production systems. The Toyota Production System remains one of the most influential manufacturing philosophies ever created, adopted by companies across countless industries. This experience gives Toyota significant advantages when introducing new technologies. Developing an innovative prototype is difficult. Mass-producing millions of reliable vehicles every year while maintaining profitability is even harder. Toyota has repeatedly demonstrated that it excels at exactly this challenge. Financially, Toyota possesses enormous resources to fund long-term research. The company consistently ranks among the world's largest automakers by sales and profitability. allowing it to invest billions of dollars annually into advanced technologies without depending entirely on external funding. Competitors are undoubtedly watching closely. Companies such as Tesla, BYD, Hyundai, Volkswagen, General Motors, Mercedes-Benz, BMW, and others continue investing heavily in battery technology and EV production. Toyota's latest announcement intensifies competition, accelerating innovation across the entire automotive industry. Consumers ultimately stand to benefit the most. Greater competition typically leads to lower prices, improved reliability, better performance, and faster technological advancement. Whether Toyota achieves every ambitious target or not, its investments push the entire industry forward. Of course, challenges remain. Commercializing solid-state batteries at scale is an enormous engineering task. Supply chains must adapt, manufacturing equipment must be refined, and production costs must fall before widespread adoption becomes possible. Delays are always possible with technologies this complex. Market conditions could also change rapidly. Government regulations, consumer preferences, raw material availability, charging infrastructure expansion, and global economic conditions will all influence how quickly Toyota's plans become reality. Nevertheless, Toyota's announcement demonstrates something extremely important. Rather than chasing headlines with flashy concepts, the company is pursuing comprehensive technological improvements across batteries, manufacturing, software, hybrids, hydrogen, sustainability, and production efficiency simultaneously. This broad strategy reflects Toyota's long-standing philosophy that lasting industry leadership comes not from winning a single technological race, but from building reliable systems capable of serving millions of customers worldwide. History suggests Toyota should never be underestimated. When the Prius debuted, many dismissed hybrid technology as impractical. Today, hybrids have become mainstream around the globe. Toyota transformed public perception once before, and it believes it can do so again. Whether its solid-state batteries arrive exactly on schedule or take a few additional years, Toyota has clearly signaled that it intends to remain one of the defining forces shaping the future of mobility. The race toward cleaner transportation is entering a new phase, and Toyota has made it abundantly clear that it has no intention of being left behind. The automotive industry is now watching closely. If Toyota successfully delivers on even a portion of its ambitious promises, its latest announcement may not simply represent another product launch. It could mark the beginning of the next major transformation in automotive history.